Suppose you have some periodic data, like for example, as we have seen in class, the number of tourists that visit some place that goes up on some time of the year and comes down in another time of the year. Of course, data will not be repeating exact numbers, but similar behavior. And suppose we want to model it. Obviously, this data looks very much like a sine function, but we have to fit a sine properly. So we consider a model where f of x is equals a plus b times sine of another constant cx. So how do we find a, b, and c? Let's see what each of these constants does to the sine function. The sine function is like this. So a, what it does, it pushes the sine up or down. It depends on the value of a, whether it's positive or negative. If our data is positive, like the number of tourists, we want to push it up. B, what it does is the sine goes from -1 to 1. So the B makes the sine goes to, sorry, this is a 1, from -b to b. So it makes this wave bigger or smaller, depends on whether b is greater than 1 or not. Let's take b positive. And then the c, what the c does is opens up the period, in the sense that the sine function repeats every 2 pi. Psi of x plus 2 pi is equals to the sine of x. So if we put a c here, this repetition here, from here to here, instead of being 2 pi, will be something else. So, given some data, how do we find? Let's consider the example we have in class of tourists in Baleares. First thing we have to observe is that the tourist repeats with a period of 12 months, because it's a yearly event. Well, a yearly event, meaning it repeats every year. So the first thing to fix is how much is c to repeat. So how do we choose c? So what we want is that the sine of cx plus 12 every 12 months has to equal to sine of cx. So what we have, cx plus 12 is nothing but cx plus 12c. We want the sine of this to be equal to the sine of cx. So there should be a difference here of 2 pi. Because as I said earlier, we have that the sine of any number plus 2 pi is equal to the sine of that angle or number. So we want this 2 pi to be 12c. And now we solve for c. We have 12c equals to 2 pi. C equals to 2 pi over 12 or pi over 6. So we have our first constant, which is pi over 6. Thus, our model fx has to be equals to a plus b sine of c pi over 6x. And now, what do we know about the sine? The sine takes the minimum value of the sine of alpha is -1. And the maximum value of the sine is +1. So for this function, its minimum value will be when sine is -1, which is a minus b. And its maximum value will be a plus b. So we make this equals to the minimum of our data. And this is equals to the maximum of our data. And what we have from here, which is a system of two equations, we get a and b, and I'll let you to find it. And we have our model f of x equals a and b found, a plus b times sine of pi over 6 times x. Let's see how good the model is to get the data. So we'll go to the Instituto Nacional de Estadística here in .es, and let's click somewhere, Estadísticas Inicio. And here we go, Estadísticas A to Z, all the statistics here. And let's look for tourists. So let's look right here, in the file, let's look for tourism. And the one we find, turismo rural, estadística de movimientos turísticos en frontera. And we're going to look at número de turistas según comunidad autónoma. So let's see, por comunidades autónomas. Now we'll consider here Baleares, el database, and we're going to take from 2015 Jan, October till 2019 December. Consultar selección, and here is the data. You want to see the graph, you can look at it here, select everything, and the graph comes. By going to the data, we're going to download the data as a XLSX, and I'm going to call it whatever. I have a file called Baleares, so I'm going to call this Baleares 2, and that saves my data. The data you save, it will look like this, but after some work, I have managed to get here is the data, and here is the sine function. You see, this is series 2, which means the sine function, and the blue is series 1, I have plot, which is the data. So look at the data in blue, look at the data in orange. It's a little bit off because of the problems with the sine, and it will require more work. But you can see it's pretty good approximation if you know the month. So you know more or less this goes to this month, top, here. In general, you can make out that it's quite a good approximation. And that's how you use trigonometric functions to approximate sine and cosine. A is here that you'll have to compute, B is here, C is pi by 6, and here are the minimum, the maximum, pi by 6, which is C, and A and B you need to find it. And this is your sine function. And that's all for today.